We have finished the original lecture, but I wanted to add an additional page because some of the problems you're going to see are using substitution. This is a long lecture. One of the benefits of taping it is that we can put in some extra material, so I'm going to do that. And we're going to begin by looking at this equation. And at first glance we say, oh, it's a quadratic, but it's x to the fourth. It's still, we would like it to be a quadratic though, because it looks like it's, should be in the right form. So we simply notice that it has the form of a quadratic equation without being quadratic. And so to solve it, we're going to use a substitution. In this case, we know that x to the fourth is the same as x squared squared. So our middle term being x squared, our first term is the square of that. That tells us what to use for our substitution. U is the variable of the middle term, as long as the first term squares that variable. Okay, does that make sense? So what we're going to do to solve this is we're going to let u equal x squared and substitute. Then I get u squared minus 7u plus 12 equals 0. Because if u equals x squared, then x to the fourth equals x squared squared, which equals u squared. That's the key, that this exponent is twice this exponent. And then I make that substitution, and I know how to solve that. But this time I'm solving for u. And I see that that should factor u minus, 3, u minus 4. And again, double check the factoring. Minus 3 minus 4 is minus 7. Minus 3 times negative 4 is plus 12. Okay? So that gives me two solutions for u. Okay, and that's not extraneous solutions, that's just basic. We don't need to check those. But what we wanted to do was to solve for x. So the last step is to solve for x. All right? And so what do? Well, I know that u equals x squared. So if u equals 3, that's the same as saying x squared equals 3, and we can solve that by taking the square root of both sides using our square root property. X is plus or minus the square root of 3. The other solution is u equals 4. In that case, we would replace u with x squared equals 4, and of course we again use the square root property, and we get plus or minus 2. So our solutions: x equals negative 2, positive 2, minus the square root of 3, positive square root of 3. So we've solved that equation by substitution. Okay? Now again, what was the key? Look at the powers. If this power is twice the middle term, then we know that we can do that type of substitution. And as you work through examples, you'll see that there are some other options for doing those as well. Okay, let's look at this next example, and the first thing I'm going to do is write it in the right form. That is, write it in the form of a quadratic by bringing the 6 over to get a 0 on one side. And then I notice that if I look at this term and square it, I get x to the negative second. So I have my substitution. U is going to be x to the negative first. Okay? And then this becomes 3u squared minus 7u minus 6 equals 0. Okay? And I can then solve. And And I think factoring will work here. In fact, I know it will. It'll be 3u and u, and 3 times 3 is 9, and then that leaves the factor of 2. You can use grouping however you can do that. Factoring is fine. And so u equals negative 2/3, or u equals positive 3. Okay, and this came from setting 3u plus 2 equal to 0, which means 3u equals negative 2, u equals negative 2/3. So just be careful in those steps. Okay? Right now that's what u is, but remember our goal is to solve for x. Okay? And so then I have two choices. Remember x, u equaled x to the negative first. So u equaling negative 2/3 means that x to the negative first equals negative 2/3. And we know that we can eliminate the negative exponent by flipping. So that becomes x to the positive first equals negative 3/2. The negative does not affect it in this case, okay? And same thing if u equals 3. That means x to the negative first equals 3, which means x itself equals 1/3. And so we have two solutions, and I'm going to let you check that they both work. And really, we have not done any squaring. We really haven't done any steps that would indicate that it wouldn't work. So we should be fine. One other thing about this problem, though, is that there's really an alternative way that we could have solved it. And I'll try and at least set it up in the little bit of space that I have here. And that is that I could have looked at my original equation once I've set it equal to 0, and I could have rewritten that without negative exponents. Okay? And I get 3 over x squared minus 7 over x minus 6 equals 0, and that of course assumes that x is not 0 as our solution. And then what could I do? Well, let me go ahead and get a piece of paper here, and I'll actually work it out for you, and then we're actually done, I promise. Okay, so let's solve that. Let's see if we can solve the equation. Three over x squared minus 7 over x minus 6 equals 0. And notice what we do. We clear our fractions. What's the common denominator of x and x squared? It's going to be x squared. So I multiply each side by x squared. Now that doesn't affect the right-hand side because it's equal to 0. Any number equal to 0 is just 0. But when I multiply through here, I'm going to get x squared times 3 over x squared minus x squared times 7 over x minus 6x squared equals 0. Okay, and I guess what I should have done, because this was what we started with, and the LCD was just x squared. Okay, and that should be 0. So the original equation, each side multiplied by x squared. Okay, now notice what that does for us. That clears of fractions. I get 3 minus 7 times 1x minus 6x squared equals 0. And so I will put that in the easier form to solve, bring everything over to the other side. 6x squared plus 7x minus 3. Make sure I did that right. 6x squared plus 7x minus 3 equals 0. Now, you might think of the quadratic formula to solve this, and let's go ahead and do that for practice. Okay? Quadratic formula. A equals 6, B equals 7, and C equals -3. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a, which is -7 plus or minus the square root of 49 plus what? 24 times 3 is 72 all over 12. Okay, do that. 4 times 18, yes, it's 72. And if I add that together, I get what? 121. And if you remember, the square root of 121 is 11. Okay? So what do I know? X equals -7 plus 11 over 12, which is what? -4 over 12 equals 1/3, or x equals -7 minus 11 over 12, which is -18 over 12, which is negative what? 6 goes into both of those, so -3/2. Now let's go back to the other way we had solved it, and sure enough, we got exactly the same solutions. X equals -3/2 or x equals 1/3. So this is a really good example. This would be a good example for you to practice on, because you can see 2 different ways to do the same equation, the same problem, and you can see that you get the same answer. And then finally, I just wanted to point out to you that I added a few additional problems to the practice at the end of lecture 5. I have reposted the video. I've reposted the note shells so that you have the new last page plus this page with lecture 5. You've got the answers, so these give you plenty of equations to practice on. And we will turn this page in, this new additional problems, those 4 extra problems along with the original practice problems. Those will be turned in as part of that written homework that you turn in to your TA. Thank you so much for your patience on this lecture. I know it was long.